Oh, no!
So that is claimed to be the footage of Elon Musk's Dragon capsule blowing up. Now, what you know for certain is this thing did have a catastrophic failure in that other pictures show large clouds of brown gas, which is nitrogen dioxide or dinitrogen tetroxide. It's the same thing. And that basically means catastrophic failure. So this immediately has some credibility like that. And I'll go over what's right about this and what's wrong shortly. Most obviously, is there any cell phone on the planet that has resolution this low these days? So what is it that can possibly blow up on this spacecraft? So those are the large clouds of brown gas that have been seen. That definitely means catastrophic failure. You've got a significant amount of fuel that has managed to get out of the spacecraft somehow. And that usually doesn't happen unless something goes very badly wrong. So what is all of that fuel doing on the spacecraft? Well, it's something part of the emergency abort system. Most spacecraft have had these, and what it basically does is if the rocket disintegrates or fails or something like that, you get a little rocket on top of the capsule that actually lifts the crew away from the exploding rocket. Now, these things are usually quite powerful. In the Apollo era, it was a solid rocket. It turns out this thing was as powerful as the first rockets that put Americans into space. And they were solid rockets, which basically means once you light them, you can't stop them. That's it. They're a one-shot deal like that. And there are disadvantages to these sorts of things. So, for instance, in the Apollo 1 fire, where there was a fire in the capsule, there was actually worry that the fire would set off the abort system, and that would have kill everyone on the pad, everyone servicing the spacecraft as well. So these things have legitimate issues to them. Now, for reasons that I don't understand, I'm going to guess it's because Elon Musk wants to reuse everything, which you can do. But in order to do that, this is the crazy thing. Once Apollo got into, well, not into orbit, but got sufficiently far up that this thing was no longer of much use, it shoots off this rocket and it's gone. Never to be seen again, certainly never reused. And with Elon Musk, they have these Super Draco engines. So that's what it's like for the Dragon capsule. So rather than it being one rocket on top, they're actually embedded into the body of the spacecraft so you can reuse them. The downside of that, of course, is that means you're carrying the fuel on the rocket the whole time. Now, what fuel do they use here? Well, it's a particularly unpleasant fuel of dinitrogen tetroxide and basically hydrazine. And it was used on the Gemini missions. These are the Titan II rockets. And the one nice thing about them is you don't have to light them. You mix these two propellants together and they spontaneously ignite. They're hypergolic. So for certain purposes, they're absolutely fantastic. So I think these were originally designed for shooting missiles at the Russians. So if you wanted to do that quickly, you sort of turn a lever, fuel's pumping to the rocket bell, and boom, your rocket's off. So they're also used for very simple engines. The one that springs to mind is the Ascent engine on the lunar lander. And what was great about these is they were pressure fed, which means there were no fuel pumps. There's absolutely nothing sophisticated about this. You just open up two valves, the fuel and the oxygen go into the combustion bell, and thump. There's nothing that can go wrong. It's stunningly reliable. And the reason they went for this on the Ascent engine is because there was no backup for this system. So it had to be really reliable. Now, it's got some nice features to it. Obviously, it's throttleable. You you pump more fuel in, you get more thrust. The downside is dinitrogen tetroxide or nitrogen dioxide is evil, corrosive stuff. You mix it with water and you get nitric acid, which is just horrific. So I think with these engines, the first time they were designed for a one-off firing. So if I remember rightly, these engines, the first time they were ever fired was when they were lit up on the moon's surface. Never tested before that. And the reason for that is because if you test fire them, you get this evil corrosive stuff everywhere, and you're better off just using a virgin engine. Now, this is exactly the same stuff that they're using for the Super Draco engines. Now, I was stunned when I saw that it's carrying almost a ton of fuel for these things for the abort system. Now, I think that's got to be, for the whole abort system. So that is divided by 4 pairs of rockets. So when we take a look at this thing firing, you will see there are 4 pairs of rockets. And I can't really find any diagrams of how those fuel tanks are arranged, but they're likely something like this. This is also actually fairly similar to how they're arranged on the lunar lander. You get these things in pairs, 1 oxygen, 1 fuel. Now, I don't know if that's for the reaction control system or for the abort system. But now it comes when they got this capsule back, it splashes down in the water, and they bring it back, and they now want to test the RCS system. And that's when you get this video, which is supposedly showing it blowing up. So what's right about this is there is this huge cloud of brown smoke afterwards. Nitrogen dioxide is basically liquid at room temperature. So if you blow it up, you're just going to get big puddles of nitrogen dioxide, which very rapidly evaporates to give this brown gas, which is what you see here. To get that much of the oxygen out, it was a catastrophic failure. So what caused that? Well, it's actually quite difficult to see how you can get this to happen, because these fuels are hypergolic, which means when they mix, they burn. They don't really explode. How are you going to get lots of hypergolic fuels to mix like this? And it's quite difficult to see how you're going to get that to happen. It's very easy to see how you can have this system fail if it's being dropped into the water. All you need is some of that water to get into the nitrogen dioxide, and that's it. You'll get nitric acid. That's a hell of a world more evil and corrosive than just nitrogen dioxide. So that would be my guess, is they got water into the nitrogen dioxide, it's corroded something up. Still difficult to see how you're going to get an explosion out of this. So the last time one of Elon Musk's rockets blew up, I did one of these analyses, which turned out to be fairly accurate. Not that it's particularly difficult. There's not that many things that can go wrong with rockets. And that was that a helium tank had ruptured, and that had caused a crack in the methane and oxygen tanks, and you can mix these fuels together without really anything happening, but they are then explosive in nature. They're absolutely lethal once they're mixed together. So this isn't like that. These are hypergolics. The second they mix, they start igniting. They're not stable as a mixture. Like with the oxygen and the methane, you mix them together, the liquids, and until you throw a match at it or give it a spark, it'll be stable. The one thing this video's got going for it is the scales are probably about right. Now, this looks like a big explosion. The reason it looks like a big explosion is because it's big compared to the size of the capsule. But you got to bear in mind, this thing has about a ton of fuel on it, which is enough to lift this capsule way up into the air, right? There's a huge amount of energy there, and this explosion is only releasing a tiny fraction of it. So what's for certain, you're only ever going to get one of these pairs of engines failing. I still can't see how you can do it. Normally, you would expect with hypergolics, the worst thing that can happen, actually the only thing that you can do that'll make this happen is if you end up pumping fuel from one of these tanks into the other. Then you'll get a fairly decent explosion, but how on earth you get that to happen, I'm not entirely certain. I mean, this is the thing about Elon Musk and the reusable spacecraft. It's been all of this stuff has been easily, well, not easily, it's been workable, outable for years. I mean, people tried it with the space shuttle with various degrees of success and failure. So with the space shuttle, of course, it didn't land in the water. In fact, the Dragon capsule originally, I think, was meant to land like the SpaceX rockets do. Again, advantages to this, disadvantages to this. If you get a failure in the retro system, then that's it. Everyone dies. Whereas if you got parachutes, it's got redundancy to it. You're splashing down in the water. It's a more reliable. It's a safer system that doesn't lend itself so well to the reusability thing. I think they might have got themselves locked into this abort system that they were going to use for the landing as well fairly early on. The thing is that they sort of scrapped the idea of having it land on dry land some time ago. So it's an obvious disadvantage having 1 ton of hypergolic propellants permanently on your spacecraft, especially when one of them is evil stuff and gets much more evil when mixed with water. So, coming back to this footage, yeah, it looks like a big explosion, but when you compare it to the size of gas these things put out when they're in the abort system mode, it's relatively minor. So you could convince yourself that this is probably only the equivalent of, I don't know, 10 to 100 kilos of TNT equivalent, that sort of thing, which is only topping out at 10% of these fuels mixing together. But you can't do it, you can't mix your hypergolics, because when you do, they just sort of immediately catch fire and spray everywhere and don't really blow up like that. So, it's a bit of a conundrum, that. So, yeah, those are my thoughts on this footage of the Dragon capsule. So if you enjoyed that, drop a like on this video, and subscribing means you'll never miss out on new content.